Today we're going to talk about the law of cosines. So again, this is something that you dealt with in geometry, but we're going to refresh your memory again. So before this, we talked about right triangle trig. That only works for right triangles. And then we talked about law of sines, and that only works if you have an angle side pair. But what about these two triangles? If we look here, we have all three sides. So this would be side, side, side. But we don't have an angle side pair in order to use law of sines. Over here, we have side, angle, side, okay, because we have the angle in between those two sides. But again, we don't have an angle side pair and we don't have enough information to find the other angle to create an angle side pair. So that means that we're going to use law of cosines, which is this crazy looking formula here, okay? And I don't want you to get too hung up on the fact that it looks super crazy, but we have a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. This part here, this a squared equals b squared plus c squared, looks very similar, okay? It looks very familiar to us because it looks like the Pythagorean theorem, okay? Normally it's a squared plus b squared equals c squared, and that doesn't matter in this case. But we have this letter and this letter must be the same, okay? So a squared equals b squared plus c squared, okay? So a squared equals the two other sides squared and added together. Then we're subtracting 2 times those same two sides times the cosine of whatever angle corresponds to that side. So this formula can obviously be switched around depending on what you got going on in your question. It's not always A's, B's, and C's either, but it has that same general concept to it. So we could have c squared by itself. If c squared's over here, that means that we have angle c, and then the a squared and the b squared are the other two sides besides this one. So we're going to square them, add them together, subtract 2 times these two sides times the cosine of the angle that corresponds to this side over here. All right, and I won't run through this one, but it's the exact same thing. So let's look at a couple of examples here of solving these. Okay, so the first one here, we're going to solve this triangle. Remember, solving the triangle means finding all three sides and all three angles. And again, this is just how I like to set things up. It's kind of up to you. So we know that angle C is 25 degrees. Side A is 8, and they don't give us units, so we can just say UN for units, and side B is 5 units. All right. So now we need to work on finding some other information. So again, we don't have an angle side pair at all, and it's not easy to do. Actually, it's impossible to do. So that means we have to use law of cosines. The only option we have right now is to find side C, because the only angle we have is angle C. That means we're going to have c squared equals the other two sides squared and added. It doesn't matter if you put 8 squared plus 5 squared or 5 squared plus 8 squared. It's commutative. Doesn't matter. Minus 2 times those two sides multiplied together times the cosine of angle C, which is 25 degrees. Okay, now when you're finding a side length, I think these are pretty easy questions because you can type this all into the calculator at once. So let me clear out all that stuff. We have c squared equals, so 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 25. And we get this. So that's what c squared equals. And I'm just going to round for right now. Okay. And then to get c by itself, sorry you guys can't see that very well, we're going to take the square root. Okay. So then c would equal, we're going to take the square root of that answer and get 4.061. Okay. And just like we did in the last video, you can store these values as well. I would get in a very good habit of storing things. It's going to become second nature for you, or at least it should be. So 4.061 units. Okay. Now that we have that, we're going to be able to do, well, to find the other information. So now we have an angle side pair here. That means that we can go back and use law of sines. Now, this is the smallest side, so it should be the case that this is the smallest angle. Okay, that means that angle B and angle A better be bigger than that. I caution you with going back and using the law of sines because of that whole second triangle case that we talked about yesterday, okay, or in the previous video. So if you want, you can solve by law of sines. If you want, you can solve by law of cosines again, and it's 100% up to you. I'm going to show you how you can use law of sines. So I'm going to find side B first, or sorry, angle B first, or next, I guess I should say. So I'm going to use the sine of 25 over, I'm just going to put C, but it's the stored value of C that we got, over the sine of angle B over 5. You could choose to do side A first, or angle A first, and then angle B. It's up to you. Again, in the very end, you need to have the largest side across from the largest angle. If you don't have that, then you're in the second triangle situation, and you got to go back and figure out how to deal with that, okay? All right, so we're trying to find angle B. So we know that the sine of angle B would equal 5 sine of 25 over C. And again, that C is that stored value of C that we have. Now, to get the angle here, that means that angle B is going to be sine inverse of all of this stuff. And again, that C is what we've got stored in the calculator. All right, so we are going to take all of this, do sine inverse of 5 sine 25, and divide it by, I'm grabbing C that I have stored in my calculator, and that's going to give us that angle B is 31.351 degrees. So far we're looking pretty good because 25 is smaller than 31.351, what we just got, which means that 4.061 should be less than 5, which it is. All right, so then we're going to store this as angle B. And then to find angle A, we're going to take 180 minus 25 and minus our stored value of B to get 123.649 degrees when we round. So the nice thing about law of cosines is that there is no second triangle unless you're using law of sines. So be very careful. In this case, if you solved for angle A first, you would be in the other triangle, and it wouldn't make sense because you get like 56 degrees here, which would give you an obtuse angle here, which doesn't make sense based on the situation. So if you want to, you can go back and use law of cosines again instead of law of sines. You just have to watch out for it, okay? So let's take a look at one more. Here, this is side, side, side. So we're given all three sides of the triangle, and we have to find all of the angles. So again, solve the triangle. We need to find all of the information, all sides, all the angles. Now, we don't know any of the angles. In this case, we know that 8 is 8 units, and B is 7 units, and C is 3 units. Now, if they give you this information, obviously we have to find a angle first, okay? That's the only thing that we can do is find an angle. My suggestion is that you're starting with the longest side or the biggest angle because that means that you're going to force yourself as an obtuse triangle. And in my experience with things, that's going to get you not to be in the second triangle. I can't guarantee it, but it's at least worth the pattern of doing, okay? So I'm going to find angle A first. That means way over here, I need to have the cosine of A, which means all the way on the other side of the equal sign, I have to have A, side A by itself. So we would have 8 squared equals the other sides, again, it doesn't matter which order, times 2 times both of those sides, and then times the cosine of A. So I left a little bit too much space there, and that's okay. Now, you cannot just type this into the calculator to get your answer. You have to take steps with this, okay? So the first step that we have to do is 8 squared. So we know that 8 squared is 64. The next step that we have to do is 7 squared plus 3 squared, and that is going to give us 49 plus 9 is 58. And then the next step that we have to do is here, okay? So negative 6 times 7 is negative 42 cosine of A. Now you got to be very careful. Here's where people tend to make mistakes. Lots of people want to take this 58 and subtract 42. This here is a coefficient for this. So if I gave you 64 equals 58 minus 42x, are you allowed to combine? Oh, you can't even see that. Can you combine the 58 and the 42x? No, those aren't like terms. Okay, so you can't combine those. We got to keep moving on. All right, so our next step then to work on getting the cosine of A by itself would be to subtract 58 from both sides. And that's going to give us 6 equals negative 42 cosine of A. So to get cosine of A by itself, we would divide both sides by negative 42. All right, so you can do that division if you want. It doesn't really matter, but we know that cosine of A is going to equal that decimal. So you could even leave it as negative 6/42. You could simplify that to be negative 1/7. It's kind of up to you. So that means that angle A would equal cosine inverse of that. Okay, so cosine inverse of negative 6/42 would give us 98.213 degrees. And then from there, we are going to need to find another angle. So we now have an angle side pair. I'm going to go ahead and store that as A, since that's what angle it is. So I'm going to do the sine of, right now I'm going to leave it as A over 8 equals the sine of B over 7. So we're solving for angle B. That means that angle B would equal sine inverse of 7 sine A over 8. So doing that math here really quick, sine inverse 7 sine, grabbing A divided by 8 gives us 60 degrees. So even though one of our angles is super crazy, does not mean that the other ones all have to be super crazy. So I'm going to go ahead and store that as angle B. You don't have to in this case. It's a super easy number to do, but that's up to you. All right, so then to find angle C, we're going to take 180 minus 60 minus that angle A that we have stored in there, not adding, and we get 21.787 degrees. All right, and double checking again, largest angle across from the longest side, and then the smallest angle across from the smallest side. And so that's how you can do law of cosines. Again, if you wanted to, instead of doing law of sines here, you can go back and do law of cosines again to find another angle, and then add them together and subtract from 180 to find the third angle. And that's it.